Hi, my name's Jim Weed. We're back to another short session on RJ Garage. We're going to inspect a distributor cap on a 308. Um, this is a carbureted car. 308 carbureted cars have got real distributors, and they've got points inside, or they should have points if they're done correctly. And fuel injected cars work pretty much the same way. Um, the carbureted cars, because they've got points and coils and all of that, is a little more complicated. So on our carbureted cars, we've got the point lead, and one end of this goes to the resistor on the coil. This obviously is the coil wire. On the other side of that, the other end of that black wire, because it's inside this sheath, attaches to the bottom of the distributor, because when the point's ground, you want to fire the coil. Uh, the distributor cap on the carbureted cars, they've got these really pretty boots on them, which help keep the water out, which is always convenient. But then again, it's a pain in the rear to take off and be able to get access to everything. So what we've done is we pulled the wire off the bottom of the distributor. We pulled the wire off the bottom of the coil at the resistor, unplugged it, peeled the boot back. We actually took off, there's a bracket here on one of the distributor bolts that I don't know if you can see that, but little bracket there that kind of holds on, because in these wire sets, you want to make sure that everything is not flopping around and loose. So once we got that loose, there's 3 bolts that hold on the distributor cap. 2 of these are real easy to get to. The third one's kind of a pain because it's right in between these wires. And these wires, these ignition wires, are somewhat sensitive. There's different types of ignition wires for most cars. You've got solid core, which is just a piece of wire inside an outer covering, an insulated covering. Those usually create a lot of noise. So from a radio noise standpoint, you want a wire that's got carbon core. And carbon core wires are mostly what you're going to find. Silicone outside, carbon core inside. The carbon runs the electricity down to the spark plug, and they're really efficient. They last a long time. These wires, on what Ferrari uses, is a carbon core wire, but around the outside of the carbon core is a spiral piece of metal. And so you've got the outer sheath, which is insulation. You've got this wire coiled around an inner carbon center, and that helps to keep radio noise down. So anytime you've got a spark running down the wire, you run the risk of getting some radio noise. All of that being said, because this is a wire-wrapped center core, you have to be kind of careful with them, because as you wiggle those wires back and forth, they'll break. Any break in the line means you end up with a chance for leakage, which causes radio noise. So you'll find on the Ferraris, everything is tied together. So we've got a little O-ring here that holds these wires together. We've got brackets that hold the wires together. So on a Ferrari, everything is held down pretty close. On your basic Ford or Chevy, you got a distributor cap, wires kind of thrown across the engine, and they can flop around all they want. One way is not necessarily better than another, just different. And so we have to recognize that when we're dealing with things that are different, maybe it takes a little different procedure. So that's why we cut this loose. We don't want to be jerking this wiring harness around a whole lot. And so what we've done is we've pulled the cap off. We're going to inspect the inside of the cap. We pulled the rotor already, and the rotors are just these little things. They spin around on the shaft, and each time a coil fires, you've got electricity that goes from the center of the rotor, goes out to the edge, and inside here, where that rotor is spinning around inside, the spark has to jump the gap between the rotor and the terminal, and then it's got to jump a gap again at the spark plug. So on all ignition systems, at least points and most electronic systems that have distributor caps, the spark has to jump twice. So it's always important to try and keep things clean. We talked in an earlier session about um, electricity is lazy. And because it's lazy, it will always choose the shortest path. It will always choose the easiest path, not the shortest path. So just because it can go from here to here, if there's a problem inside this rotor, then it may go somewhere else, probably not where you want it to go. It'll go somewhere else and not go down the wire that you want. And we call that crosstalk, where the distributor electricity in the distributor, that spark's flying around because it's going to other terminals. It may be easier to jump to a different terminal in here because it's dirty and jump through a spark plug that's not ready to fire. So you can end up with backfire and some other problems, basically running problems with the car. So what we're looking for is we want everything to be clean. We want it to be sanitary. And so what we're looking for is the center carbon on the rotor to make sure this is clean, that there's no pitting or scoring or burn marks. This should It'll be dirty because there's carbon, and I'll show you that in a minute. But it can be dirty in here, but you want to clean that off. Once again, we want a good path for the electricity. We want to make sure that the end of it in here is clean. And you'll see when you look at rotors that they're kind of burned on the end because you got sparks going on, and the sparks will damage, one side versus the other. Fortunately, the way most distributor caps are made, the tip on the rotor is kind of soft. The terminals in a distributor cap are harder, and so typically your erosion, your electricity erosion from the spark is going to be on the softer metal, thinner metal, and that's good because these are easy to replace. Distributor caps are a bigger pain in the rear, and that's pretty much true on all vehicles. So that's what we've done here to start with. Is we've looked at the rotor, we've looked at the tip. The tip's not burned real bad. It's got a little bit of pitting on it, not bad. So this is okay. So we're going to let that ride. We're going to go to inspect the inside of the distributor cap. And the first thing we want to look at is that center carbon. And this carbon button in the center is spring loaded. And so it should have some spring to it. It should be sitting up above, so that when this cap goes on, that spring is going to push against that rotor, the center on the rotor. And we want to look at that carbon and see, is that carbon burned? Is it irregular? We want it to be, really nice and shiny. They're domed. So because they're domed, they'll only touch in the very center. And so as electricity is being conducted through it, that carbon is just kind of resting in the center of the rotor and making good contact. So that's kind of your first inspection on a distributor cap. Your next step is to look at the terminals. So where that rotor is flying by these terminals inside here, you want to look at those and see if they're clean. And I'm sure in the video you can't see it very well, but you want to go in and kind of clean those terminals up. You want to scrape them off. There'll be flaking on there. Um, you can have crud buildup. Basically, as you look inside the distributor cap, it should be clean. It should be dry. There should be no oil. You should not have any liquid inside here. And you want these terminal ends to be clean. So what we'll do is we'll kind of scrape these off first to get the crud off of them, and then we'll go in and we'll put a little sandpaper on it and just kind of shine them up. They don't need to be super clean. Coils put out about 40,000 volts or so, so there's some pretty high energy going through this. But you just want to make that path for the electricity as clean as possible. The next step would be, while we have this cap off, we'd pull each spark plug off, each terminal off each spark plug, and we would ohm that wire. Ohming wires pretty straightforward. Get your multimeter out, put it on ohms, and ohm the wires. There are specs for how much resistance you should have in the wires, and they vary from car to car and the type of wire and all of that. So I'm not going to give you those specs, but generally what I look for is short wires are going to have less resistance than long wires. So I always start either end, makes no difference. Start with a short wire, work your way to the long wire, or start with a long wire, work your way to the short wire. But what you're looking for is a nice even progression of ohms. So whatever the ohm number is on your short wire, it should be a little more. On the longer wire, it should be a little more, little more. So as you add length of the wire, you're going to add resistance in the wire, and so that's going to change your ohms. And that's all you're looking for is a nice even progression. If you're going from, and I'm picking numbers, 1,600 ohms on one, 1,800 ohms on another, 2,200 ohms on another, and 2,800 ohms on the other, that's a nice progression. So, don't sweat the actual number. On old wires, a lot of times you can just bend the wire and change the ohms. That tells you that center carbon inside is getting old and may still be good because it's conducting electricity, but those are kind of some things that you want to look at when you're ohming wires. But with these wires, because it's a Ferrari, because these are uh, wire wound center cores, you don't want to be jerking them around. So typically, we'll take them off as easy as possible. We'll ohm them. We don't really jerk the wires around. On your American car, on a modern car with modern wires, you can do that. On a really modern car, they don't have wires at all. They got coil unplug. So right where the spark plug would be, you got a coil and you got electrical connection. Those are easy peasy because either it works or it doesn't. You don't have to mess around with wires. And we'll get into points on one of these episodes and discuss, what it takes to replace points and to check mechanical advance on the Ferraris. Most of your American cars have got vacuum advance. They've got mechanical advance inside. They've got vacuum advance on the outside. So the mechanical advance just advances the spark the faster the engine turns. And so as an engine is speeding up, you really want that spark to kind of start sooner. And maybe we'll have a discussion one day about why and how. That starts to get into the weeds above and beyond what we're doing here, but just kind of to give you a clue, you want the spark to start sooner the faster the engine turns. So that's pretty much what we're doing here. The other pieces that we're going to look at before we button this up completely is we'll check these other contacts. This Ferrari, most Ferraris have got dual points. Some of the cars had dual points, like on a V12. One set of points will run 3 cylinders. The other set of points will run the other 3 cylinders. The other distributor, because we got 2 distributors, the other distributor would run 3 and 3. On these cars, on the V8s, typically one set of points runs 4 cylinders. The other the other distributor runs 4 cylinders. So these are 2 4-cylinder engines basically separated. The extra set of points in here is what we call retard points, and there's a switch in here, and it's all part of emissions process so that when the engine is cold, it actually retards the timing a little bit and makes it easier to start when it's cold. As the engine warms up, then the retard points stop working and contributing, and they don't come into play anymore. It's running off the second set of points. A lot of people will take out the retard points because, the car will run so much better without the retard points in there. And that's where people will screw up a Ferrari, a carbureted car. Carbureted cars work good with both points working, set up correctly, timed correctly. It's a wonderful system, fairly low maintenance. Overall, you can get 30,000 miles or so out of a set of points. And obviously, uh, we're not driving 308 carbureted 308s 30,000 miles a year. So, you can go a lot of years before you need another set of points or need to have the points adjusted. So that's your inspection. Um, I will tell you that we did the easy side. When you're working on 308s, everything is difficult. Everything is a pain in the rear. So we're working on the 1.4 bank here, the 5.8 bank in the back, or I say the back, it's really to the front of the car, but the 5.8 bank is even more a pain in the rear to do. But like doing anything on a Ferrari, it's take your time, go slow. It's one bolt, one nut, each time. That's all you concentrate on is, all I'm gonna do is take this off. And once you get that off, then it's, okay, now we're gonna do the very next thing. And, none of this is difficult, none of this is hard. Um, Pain in the rear, but not impossible. So if you've got a 308 and you wanna do an inspection, you can do it. It's, pretty straightforward. I'm Jim Weed, RJ Garage. Thank you for watching this little segment, and we'll be back and have more fun later.